In this video, we focus on iterated integration. Let's start off with the definition. Given a function f of xy which is continuous on the finite rectangle AB cross CD, then the integral over the region R is defined to be integral from A to B, that of C to D, f of xy dy dx, which is equal to integral from C to D, then A to B, f of xy dx dy. So here we should know that A to B is for the x-axis and C to D is for the y-axis. So if we want to integrate x first, then the range of integration should be that of AB. So with the last equation, we are integrating with respect to x first. We should have the range of integration being from the x-axis. And with the first one, we were integrating with respect to y. So we should have the range of integration being that of the y-axis. These integrals are known as iterated integrals. So now equation 1 is known to be the Fubini's theorem. Let's start solving some examples associated with iterated integrals. So here we are being asked to compute the integral over the region R, which is defined to be 0, 1 and minus 1, 1. So here this point is for the x coordinates and that of this one is for the y coordinates. And we have our function f of xy being defined to be this guy. The first step is to set up the double integration. So we will have the double integral of 5x squared minus 4y squared. So here we are integrating with respect to y first. So we are going to have here to be minus 1, 1 and here will be 0, 1. Or one may also choose to integrate with respect to x first. In that case, we are going to have the double integration 5x squared minus 4y squared, then dx dy. So here, since we are integrating with respect to x first, here will be 0, 1, then minus 1, 1. In this question, we are going to use the integral on the left hand side to compute our integral. So we are going to integrate with respect to y first. Here we integrate the inner integral first. So we are going to have integral from minus 1 to 1, 5x squared minus 4y squared dy. Now let's integrate this guy with respect to y. So we are going to have 5x squared y minus 4 on 3y cubed. Then from minus 1 to 1. Here we're now substituting the range of integration, so that's going to give us 5x squared 1 minus 4y3 1 cube, then minus that of the lower range of integration. So we are going to have 5x squared multiplying minus 1 minus 4 on 3 minus 1 cube. So we just have to simplify this guy. So that will be 5x squared minus 4 on 3. And then here is minus, so that will be plus 5x squared. Then minus 1 cube is minus 1. So minus 1 times minus 4 on 3 will be 4 on 3. Then times this minus. So that will be minus 4 on 3. So we just have to simplify this guy further. So we are going to have 10x squared minus 8 on 3. Here we now substitute 10x squared minus 8 on 3 in place of what we have here. So now our integral is going to be integral from 0 to 1, 10x squared 8 on 3 dx. Now we can now integrate this guy with respect to x. So that will be 10 over 3 x cubed minus 8 over 3 x from 0 to 1. So we're now substituting the range of integration, the upper range minus that of the lower range. So that will be 10 1 cube on 3 minus 8 on 3 times 1. Then minus that of the lower range. So that's going to give us 0. So that will be 10 on 3 minus 8 on 3. So now we now have to simplify this guy. So that's going to give us 2 on 3. Hence our answer is 2 on 3. With our second and last example, our rectangle is defined as -2 -1 cross 0 1, and our function is given as follows. So here we follow the same procedure as we did for the first one. Setting up the integral gives the double integral of x squared plus x cosine of y plus 5xy. We can choose to integrate x first, so here will be the x, then we integrate y last. So thus the range is going to be -2 -1 then 0 1. So then we take out the inner integral, then we integrate that one first. Integrating the inner integral gives x cubed on 3 plus x squared on 2 cosine of y plus 5 on 2x squared y, then the range of integration -2 -1, because substituting the upper range of integration gives -1 cubed on 3 plus -1 squared on 2 cosine of y plus 5 over 2 -1 squared y, then minus that of the lower integration. So that is going to give us -2 cubed on 3 plus -2 squared on 2 cosine of y plus 5 over 2 -2 squared y. So we just have to simplify this guy. So that's going to give us -1 on 3 plus 1/2 cosine of y plus 5 over 2y, then minus -8 on 3 plus 4 on 2 cosine of y plus 20 on 2y. We expand the left hand side and simplify further. So we are going to have -1 on 3 plus 1/2 cosine of y plus 5 over 2y plus 8 on 3 minus 2 cosine of y minus 10y. Adding like terms gives 7 on 3 minus 3 on 2 cosine of y minus 15 on 2y. Thus the inner integral is given below. Here we have to substitute our answer back into the original integration question. Then we now integrate with respect to y. Integrating with respect to y gives 7 on 3y minus 3 on 2 sine of y minus 15y squared on 4 from 0 to 1. Substituting the range of integration gives 7 on 3 multiplying 1 minus 3 on 2 sine of 1 minus 15 on 4 1 squared minus 7 on 3 multiplying 0 minus 3 on 2 sine of 0 minus 15 0 squared on 4. Simplifying this gives 7 on 3 minus 3 on 2 sine of 1 minus 15 on 4, and the left hand side will all go to 0. This is going to give us minus 17 on 12 minus 3 over 2 sine of 1. Hence our answer is given below. Thank you for watching. See you in the next video.